Alright, this is another video on sketching the graph of a rational function. This is really, really important stuff. It shows up everywhere. This is one of those things that you learn in pre-cal and in Algebra 2. It actually shows up on the AP Cal exam. So let's just go through this a little bit. First thing I'm going to do, if you don't mind, is I'm going to kind of look at this function this way, as if this part right here is if the numerator was f of x, and this is as if the denominator was g of x. It just helps me to look at this. So it doesn't matter where you start. I'm going to start here by simplifying this a little bit. And how do you know you should simplify it? I don't know. Take a look at the two functions, f of x and g of x, and look at them and ask yourself, do you think they could have any common factors? If you think they have common factors, then it's probably worth your time to try to factor them out a little bit. So I'm going to try to factor this top piece out right here. So I'm just going to rewrite the function. Sorry, this is not prime. As f of x here, and I'm going to try to factor this, and just with a little bit of work I realized that the factors here are x plus 2 times 2x minus 3, and if you're sitting there saying, Charlie, I suck at factoring, like, I'm not trying to be funny here. Go back to your Algebra 2 book and start really working on that, because it's a skill that you're going to use a lot, especially in college. It just comes up a lot, so it's worth going through this. Let me just say this. If you do factor this and you're not sure, just refoil it, right? Re-expand it and see what you get. So multiply this times this and do your FOIL and see if you don't get that back. From here, this piece down here should be relatively easy to factor because we have an a value of 1 here. So we know that we're going to get x here and x here. And I don't know if it's factorable or not. We need two numbers. When we multiply the two numbers, we get positive 2. When we add those same two numbers, we get positive 3. And I think those numbers are positive 2 and positive 1. So looking quickly, we see that this function can be simplified. It's important that we see this. So this is in factor form. A factor of x plus 2 over a factor of x plus 2 is actually equal to 1, and they can be canceled out. So this function is actually 2x minus 3 over x plus 1 is the function, right? The redefined function. It's still an equivalent function, but what we do have to take into consideration is that this was here, and therefore x cannot equal 2, right? X can't equal 2. So what this means is we have a hole in the function. So we have a hole. Wow, I really wrote that, didn't I? That's embarrassing. Hole, different hole, right? Hole at the point, and this is a negative 2, at the point negative 2 what? That's the point negative 2. And if we drop this negative 2 into this part of the function right here, we'll find out that x is equal to 7. X is equal to 7, right? Isn't that right? Yeah, x is equal to 7. So there's a hole, and we have to remember to graph this later. And hopefully I'll remember. So maybe I should put a star or something next to it to help me to come back to that thing. So I'm going to move on a little bit here. And now we're just going to do this. Figure out, do we have any vertical asymptotes? So vertical asymptote, question mark. Well, vertical asymptotes are caused by g of x equaling 0. So x plus 1 equals 0 when x is equal to negative 1. That means we have a vertical asymptote at x is equal to negative 1. I'm going to go ahead and start graphing this a little bit. So here's this. We have a vertical asymptote at x equals negative 1. Is that right? At x equals negative 1. So that would look like this, wouldn't it? And you actually, when you draw this in, you should draw it in as a dotted line, and then name that. And this is x is equal to negative 1 here, right? Now the next question is horizontal asymptote. So how do we find the horizontal asymptote? So we go back and we want to know what the horizontal asymptote is. Horizontal asymptote, question mark. Horizontal asymptote is done this way. We go to the original function and we compare the highest exponential value of a variable, numerator and denominator. So here this one has the highest exponential value of a variable of 2. And this one also has of 2, so they match. So these are usually called n and k. So if n and k are the same, then what we use is a ratio of the lead coefficients. A ratio of the lead coefficients. So this one has a lead coefficient of 2. This one has a lead coefficient of 1. So that means we have a horizontal our horizontal asymptote is y equals 2. So we have y equals 2, so y is equal to 2. And then we're going to draw that in also, and all we have to do is here just estimate this line. It's a horizontal line, right? Again, the protocol is that we are supposed to label that, so here's y is equal to 2. All right? We only have actually two intervals here, so our intervals, right? Right, because we know that our function does not pass through this vertical line, right? We know it definitely does not pass through this vertical line. So as it approaches from the left to the right, it either does this and bends down like this, or it goes like this and it bends up against this. And which one does it do? Well, we'll figure it out, but first let's agree that, so that leaves us two places, right? X is not equal to -1, can't be, but it could be equal to anything less than that, so we have x is less than -1, right? And we have x is greater than -1, don't we? So just take some value, and if we take, oh look, we got one for free, didn't we? Because look, we got this one right here, so we know what happens here, right? We have this point up here, so this thing does this. It does like this, and it rushes up like that. Remember, it's going to push up against that thing right here. How do I know that? Because we did this, and we know it as a hole here, so we know this point exists. So here's our hole, and we're just going to actually draw it in as a hole, and we're going to label it -2, 7, right? If this is -2, 7, it has to go from here to here. It has to be going up because it can't be under this line here, right? It has to be over it. So we don't have any choices. We know we have a point over this, so they're all over that. And let's see what else we might have here. Let's take a point that's greater than, oh, let's take this one. Let's take x is 0. So this is right. X is 0, so x is 0. So let's take f of 0. And f of 0 equals, let's go back up to this function right here. Whoa, baby. Take f of 0. And f of 0 is -3, isn't it? F of 0 is -3, so we get the point 0, -3. Well, it's going to pass through this point, right? And we know, because of its asymptotic relationship here, that this thing is going to be approaching this x-axis. It can't do it this way, because if it does, it's going to have to cross this, right? So it's going to do this. It's going to approach that. And we know that it's in behavior, because that's what horizontal asymptotes tell us, right? Horizontal asymptotes only tell us what the end behavior is. People get really confused, but it just says as x approaches -infinity, this function is going to approach a height of 2 as it goes infinitely this way. And the same thing as it goes infinitely that way, it's also going to approach this. So I think we have our graph. All right. I hope that was helpful. Look, some of the stuff you just have to memorize, like what are the parts of a graph, and we want to know what the general shape of the graph is. We want to know vertical asymptotes, we want to know horizontal asymptotes, and we definitely want to know end behavior. So those are the kind of things that you want to talk about. And from these things, we also get domain, right? The domain of this function is that x can't equal -1 or -2, right? Okay. All right. I'm as happy as I can be. I hope it was helpful for you. Here's all my proof. I was just checking it out before I did it, just so you know.